So today we're going to take the idea of similar polygons or similar figures from the last section and proportions, and we're going to apply it to the real world and do something called indirect measurement. So imagine you wanted to know how tall this tree was in the picture, but you can't measure it directly. You can't take a measuring tape and get up there. Or you wanted to measure across water or something like that. You can actually use triangles and the idea of similarity and proportions as the math behind it to figure out what those distances are. Now, before we go anywhere, here's just an example of one of the pyramids in Egypt, and you got a guy out here with a rod or something. And you're going to notice there are two triangles. They look to be right triangles. And if you look at them, the corresponding angles, so the angle pair is this one here and this one here, this one in the right-hand corner, this one in the right-hand corner, and the top two, they all look to be congruent. They all look to have the same measure of degrees. So this one and this one in the right-hand corner and that one, and the top two, they all seem to be congruent. So if the sides were proportional, we would know that those two triangles are similar from our last section. So using indirect measurement, you can use the properties of similar polygons to find that missing distance that you cannot measure. So first of all, before we go anywhere, you just have to understand that really knowing two angle pairs that match up. So if you look at these two triangles, if I was to tell you that angle A, which is the obtuse angle that I'm sort of tracing down here, is congruent to angle F. So they have the same number of degrees. And then I was to tell you that angle B in the lower right has the same degrees as 6. They're congruent. Then the two triangles would have to be similar. The third angles would have to have the same measure. They would have to have the same measure because they add up to 180 degrees, which we learned a long time ago and reviewed. We learned it in 7th grade. We reviewed it a couple months ago. So knowing that two angle pairs match up, the third angles have to match up. And once you have that situation, the two triangles have to be congruent. If you look here, if you know that this angle P and that angle X are the same measure, and the same thing with Q and V, there's really only one triangle you can get here if you extend those sides, and the same thing here. And just look at them. They are the same triangle, just different sizes. So there's a thing called the angle-angle similarity, that AA standing for angle-angle. And it just means that if you had two angles in two different triangles and they have the same measure, then those two triangles have to be similar. Their sides have to be proportional. So we're going to use that idea going forward to find sort of those missing lengths of the tree and the distance across the water. So just to kind of start with some questions just about similarity and the two angles. Let's say I gave you these two triangles and I said, are they similar? And if they are, you're going to write a statement that says one triangle is similar to the other. Well, right now I can see that angle E and angle A are congruent. They have the same number of degrees, but F and C sure don't. But what is angle G? So remember that these three angles have to add up to 180 degrees. So if I take 180, take away the 62 degrees of angle E, take away the 48 degrees of angle F, that result will be the measure of degrees for G, which is 70 degrees. Hey, listen, we got a 62. Yep. We've got a 70. Yep. And then this missing angle, if we add those two and subtract from 180, must be 48. So the two triangles have, all those angles that match up. So they are similar. We only need two, but we have a 62 and a 62, and we have a 70 in G and a 70 there. The two triangles are similar. Now, when you go to say that the two triangles are similar using our similar symbol rather than writing the word, remember the order of the letters matters. So when we write A, B, C, the first letter here has to be the angle that matches with angle A. It's called corresponding. And remember, A was 62 and E was 62, so E has to come first. Angle B over here would be our 48-degree angle. He would match with F. And angle C, which is 70, would match with G, and that the order matters. Okay, so how about these two? Now, wait a minute. Mrs. Woodruff, you only gave me one pair of angles. Not so fast. Look at the X here and notice that we have angles on opposite sides here, one to the left and one to the right. They're a special angle pair that we learned about earlier in the unit. They're called vertical angles, opposite V's. And we learned that vertical angles are congruent. They have the same measure. So without even going any further, L and H are congruent, and angle HKJ is congruent to LKM. We've got two angles in both triangles that are congruent, so they are similar, and we're going to put them in the right order. So H has to go with L, and K has to go with K, and J has to go with M, and that's a similarity statement saying the two triangles are similar. So, who cares? Why, Mrs. Woodruff? Because that's what's going to allow us to measure this darn tree. Because we know or hope that the tree is making a right angle with the ground, and the woman is making a right angle with the ground, and we're measuring them on a sunny day, so the sun is up here, and the angle that the sun makes with the tree, along with the angle that the sun makes with the lady here, would be the same. So we'd have two pairs of angles that match, and therefore we would know these two triangles are similar. And we can use a proportion to find that missing height. This is called shadow reckoning. And I actually remember in my high school that there was a physics teacher who would sort of send his class out with a measuring tape and ask them to measure the flagpole. And that were the only directions that were given. The teacher made sure it was a sunny day because that was the only way they could really measure the flagpole without scaling it. So what they would do is they would measure their height. So say it was me out there and I was 5 feet tall. And they would measure my shadow. And then they would measure the shadow of the tree and they would set up a proportion. So in the top row, we're going to put the height to shadow. And then we're going to put height to shadow. So on this left side, there is the woman at 5 feet tall and her shadow is 3 feet long. And then the tree is, we don't know what height, but its shadow is 7.5 feet long. And then if we go back to the last section we did, we're going to take 3 times H, has to equal 5 times 7.5, which is 3H equals 37.5. And if you divide both sides by 3, your height will be 12.5 feet. And we know that the tree is 12.5 feet. That's called shadow reckoning, indirect measurement. So here's another example where we have the height of a lamppost and its shadow. Notice it's getting maybe later in the day or earlier in the morning because notice how long the shadow is. Or maybe it's in the winter when the shadows are longer, the sun's further off on the side here. Now here is a fire extinguisher that also has a shadow. So we're going to do the same thing. We're going to put the hydrant, which is hydrant's shadow rather is 5 feet. Now notice there's another way we can set up the proportion where in this case they're going to go shadow to shadow. So hydrant shadow to lamppost shadow. And now when we come over here, we need the actual hydrant to the actual street light. And then we're going to do the cross products. 5H equals 26 times 2.5. We're going to multiply, and to solve this one-step equation, divide both sides by 5, and you can figure out that the lamppost is 13 feet tall without ever really measuring it, using shadow reckoning and indirect measurement. So here's one that often confuses people. Just because the two triangles are no longer apart, they're overlapping. So I'm going to trace, if you could just watch the triangle up above, you can see the triangle ABD is sitting on top of a bigger triangle ACE. And these two triangles are similar because we've got the same right angle here in the bottom right corner. And then you can see they share angle A, so that has to be the same. So these are two similar triangles. So I'm going to set up a proportion. And so I'm going to take the AB, which is off of the smaller triangle, it's the hypotenuse, and I'm going to put that to the longer side of the other one. So this is the hypotenuse to the hypotenuse. So 320. And the hypotenuse of the bigger one is 320 plus 162. It's this whole length, which is 482. Now I'm going to go back to this smaller triangle, and I'm going to take the BD, which is 40, and it would match up with the D on the other side. And now I've got my proportion. I'm going to take the cross products. 320 times D equals 482 times 40. Multiply these in the calculator to get 19,280, and then solve the equation by dividing by 320. And the distance across that lake would be 60.25 meters. So if you want to measure across water or something that you can't measure across, as long as you can do some of these measurements on land, you can figure out what the distance across the water is. Okay, so here's a chance for you to do one. At the same time, a 2-meter street sign casts a 3-meter shadow. So the sign is 2 meters, the shadow is 3. A nearby telephone pole casts a 12.3 shadow. And you want to know how tall the telephone pole is. I would draw a little diagram, I'd write my proportion, and I would solve it using the cross products. Please pause the video, write this out, and turn it on again when you're ready to check your answers. So let's see how you did. Here's the street sign shadow, telephone pole, which I don't know, shadow. And I decided to do the object to its shadow. So 2 is the street sign to its shadow of 3 is the height of the telephone pole to 12.3. Now that's not the only way to write this proportion. Some of you might have put 2 over h equals 3 over 12.3, and you should get the same answer. There's actually 4 ways to write this good proportion, but there's also 4 ways to mess it up. So now I'm going to cross multiply. 3h equals 2 times 12.3. I multiply and then divide by the 3, and the height of the telephone pole would be 8.2 meters. Did you remember to write your units? Okay, so we're just going to practice everything we've done here really quickly, but these first 2 problems, are the 2 triangles in the picture similar? And if so, you're going to write a similarity statement, which is like triangle ABC is similar to triangle QRS, that type of thing. So pause the video and do these 2, please. Okay, let's see how you did. This is the first thing we talked about today. So because these are vertical angles, the left hand, which is YWX, and the right hand, which is VWU, those 2 are congruent. And we already know that angle X and angle V are because they have the same measure. So these 2 will be congruent. So triangle YWX, so Y to the W to the X, would be congruent to U to the W to the V, and the order matters. Y has to be in the same position as U, W has to be in the same position as W, and X has to be with V. You could have written, for instance, triangle WXY, but then over here you would have to write WVU. So just have to make sure they match up accordingly. Over here, I took 180 minus the 90 plus 35 is 125 degrees that were used up, which means the third angle would be 55. And since this guy is not 55 or the 35, there's no way they can be similar. So there's an example of each, a yay and a nay. Okay, so let's just do some shadow reckoning, which is the whole point. Can you find the height of this tree? Pause the video and give it a go. Okay, let's see how you did. So I'm just showing 2 different ways to do it. As long as you got the tree to be 3.3 meters, doing good math, you're okay. But you could have done like small shadow to big shadow, so 0.3 to 2.2, and then go back and do the 0.45 is to h. And then you would cross multiply these, divide by 0.3 to get the 3.3. Now over here, I took the dog's shadow on top of the actual dog and the tree's shadow on top of the actual tree, cross multiplied, and got the same answer. So there were 4 good ways to do it, and this is just 2 of them. You obviously only have to do it one way. Okay, the last one we're going to do today is kind of with these triangles that are kind of crisscross. They make the X in the center. I've put in measurements to let you know that these 2 angles are congruent, and obviously the 2 vertical angles are as well, but I just want you to know who goes with who here. So in order to get this triangle to lay on top of this one, you would have to rotate it 180 degrees and then dilate it down to get there. So here are the answers here. And did you get 10 meters? And there is a good proportion to do that. So today we took our similar figures one step further to see how we can use it in the real world doing indirect measurement. So tomorrow you're going to just give it a practice. And this is the last topic of the year. So, and a useful one at that. I hope everybody has a great day.